Once that end area model is designed, we can also immediately calculate the areas of the takings and remainings necessary. In fact, it's not even necessary to have an end area model. CEAL can calculate areas within any enclosed chain stored in the database, but you can see how powerful that would be to calculate takings and remainings. Another right-of-way feature is the draft legal description. CEAL will output a legal description along any chain within the database. It's also a customizable description. The text of the description can be set by the user, and when the command is invoked, the system goes to the database, grabs the bearings and distances, puts them into that text file, and displays it for you. The system will also plot these end areas automatically for you to create your cross-section sheets. We're being prompted now for the grid size and the pen to use. Simply by telling the system the spacing between the cross-sections and the top and bottom of each sheet, the system will automatically fit those cross-sections on the sheet. You can see that the cross-section report also has yardage block up the right-hand side. And these are now ready to be sent to a plotter. We'll plot one more here. You can see that the roadway is super elevated through this area here. Here's another extremely powerful feature of the schedule files we talked about earlier. Not only can we display the graphics associated with each class of elements on the screen, but we can get a quantity tabulation associated with each classed element. For instance, sidewalk might be classed SDWK, for instance, and a unit value of $200 a foot might be associated with it. The designer can have the system go through his database, use the unit values he input, and calculate an estimate of quantities from the database. By a little description, the classification, the unit value, it finds the length of the area of each associated item from the database and does the extension for you. That database concept is so powerful. When we looked at the end areas and the volumes, if the designer were to change the vertical profile of the roadway, he then has a new legal description around the takings and remainings, new areas for the takings and remainings, new volumes, new mass haul diagram. Because the designer is designing to the database, all those other quantities are updated automatically. That's one of the true powers of the system. Now we're going to see a feature that's unique. This is called redesign, and allows us to look at each cross-section individually and interactively modify or display things about that section. So we use the mouse and the pull-down menu here on the right side of the screen, and we can select the display option. See, we get the on-the-fly offset and elevation calculations as we move the mouse through the window. And we'll select a link, and it highlights and we're displayed all the information about that link. In addition, we can modify a link at this point. We'll select the link to modify over here, the left back slope. See, the link is highlighted. Width is 18.2 feet. Delta Z is 4.55% slope, ratio slope, so on. We'll select modify width, and we're prompted for a new width. We'll go from 18 feet all the way down to 5 feet so that the change is real apparent. And now when we select update, you can see that the template has changed at that station. And now we can end, and we're given the option of discarding our change or saving it. And the designer can scroll through his cross-sections one at a time that way. And if he chooses to save one of those changes, he can save these as separate alternates, of course. All those other things are automatically updated. The plan and profile sheet will be updated. The volumes are updated. The mass haul diagram is updated. The areas within the takings and remainings are updated. The legal description is updated. You begin to see the power of that database. Well, the last thing we have to show here is a perspective view And this is something that could be used, I think, to great value at a public information meeting, because it helps convey to the public or the layman some of the concepts of what this roadway might look like. Because you have a digital terrain model, you have the ability to cut cross-sections at whatever interval you like. There's nothing to prevent you from cutting cross-sections every 5 feet as we've done here. And when you display this in a perspective view format, I think you get a very good feel of what this design is going to look like. Now this can be taken into an image processing system, overlaid with homes, trees, and so on to pretty it up. But the geometry here is correct from a perspective view format. Now you can see that this is one of the alternates that we did. It has a benched cut in the roadway, and this benching is performed automatically by the system when we're in a certain depth of cut. In addition, you'll see another patch of perspective view show up here. Not only can you cut cross-sections at any interval, you can also construct cross-sections at any width from the same model. So we'll see now a 24-foot wide swath cut through the digital terrain model representing the pavement. I think that gives a pretty good representation of what this will look like. Well, that concludes everything that we had to show in the online demonstration for the managers, overviews, and the new users of CEAL. You can see that this new capability, CEAL running on the Apollo workstation, is putting for the first time in the hands of these designers a capability to have interactive graphics and design modeling. And we're going to see increased productivity from this, as well as improved plan quality.